Example 2 asks you to graph the function of 1 minus 6 times the cosecant of the quantity 3x minus 16. So again, cosecant is a reciprocal of sine. So remember, we want to graph our denominator to figure out where my asymptotes are, meaning where I'm going to have an output or a y value of 0, so it's undefined. So what I want you to do is pause the video and sketch y equals 1 minus 6 sine of 3x minus 60. So this is using all the information that we've been doing for the past week. So unpause the video once you have this graph sketched. Okay, so by now you should have graphed the sine function. We have a displacement of 20 degrees to the right, and then we also have a period of 120, so I'm going to end at 140 degrees because 20 plus 120 is 140. Okay, so again, we sketch our denominator function to figure out where my asymptotes are located, and again, that's where my denominator function, the sine function, crosses the midline. In this case, it's y equals 1. Okay, so what I want to do is graph my asymptotes. So remember, these are dashed lines. Okay, and then we're just going to continue, and we have to graph the shape of it. So if I have a minimum, remember we're inverting cosecant and sine are reciprocal functions, so we're like inverting the numbers. So if I have a minimum, it's now going to be a maximum. And remember, you want both your lines to approach the asymptote. You don't want them to cross over. Okay, and make sure I see a nice dot at the vertex to make sure I know where your min or max is. Okay, remember, you need to graph one period's worth, at least one period's worth. In this instance, I do have one period's worth because between 20 and 140, the graph does not repeat. Okay, now if I were to identify, the 4 translations of my given function, my amplitude would equal 6, because remember, it's the coefficient in front of the function. My vertical shift would be 1. My b value would be 3. And so to calculate my period, I chose to use 360 degrees because my displacement is in degrees over 3, so my period's going to be 120 degrees. And then again, my displacement here is going to be 20 degrees because that's when I set whatever's inside the parentheses equal to 0 and solve. So here you have a cosecant function.